So what if your AI go beyond its training data and actually learn from your documents? No guessing, no hallucination, just real answer pulled directly from your own file. That's RAG. So regular AI doesn't know your company docs, your research paper or your private notes. It can search the web, but it can't search your files. That's exactly what RAG, Retrieval Augmented Generation, solves. But here is what most people miss. RAG is a system, but learning how to calibrate is a skill. So how you check your data, what similarity threshold you set. This decision determines whether the RAG works well or fails. So today I will show you exactly how the RAG system works end to end. We are going to break it down to 3 simple steps. First, we'll build the complete local RAG system from scratch using a tool called AnythingLLM. So we'll start from very beginning, installing Ollama, uploading the documents and getting everything run locally. Second, we'll look at the under the hood. As we go, I'll explain the concept like chunking, embedding and vector database in a more practical way. And finally, I'll walk you through the settings that control the RAG performance. Things like chunk size, similarity threshold and temperature, so you know how to tune it for your own use cases. So by the end of this video, you won't just have a working RAG setup, you actually understand how the entire system works behind the scene. So if that sounds interesting, let's jump straight in. Alright, so before we start installing anything, let me quickly explain what we are building here. So we need two things to make the RAG work locally. First, Ollama. This runs the AI model on your machine. Think of it like a brain that generates the response. Second, AnythingLLM. This is a RAG platform, it handles everything. Splitting your documents into chunks, converting them into searchable embeddings, storing them into a vector database, and retrieving the relevant pieces when you ask a question. So in a nutshell, Ollama provides intelligence and Anything provides the memory. Together, you get an AI that actually read and answer your own documents. So let's start with Ollama. Great, let's check our system first. I'm on Windows 11 with 32 GB of RAM. And you don't need this much 16 GB works too. So if you are on Linux or Mac, same process, nothing changes. So first thing we need is Ollama. This is where we run the AI models locally on your machines. So let's head over to ollama.com, go to the download page and grab the installer for Windows. So one command in PowerShell, paste, so let it download. Once Ollama is installed, let's verify the Ollama version and we are good. So now we need a model. So let's pull Ollama 3. This is a Meta latest model, around 4.7 gigs for 8 billion parameter versions. Good balance of speed and quality. So let it download. And we can verify using the Ollama list command. And there it is, Ollama 3 is ready to go. Quick test, Ollama run, then the model name, then put the message. And you can see a response coming from our local LLM. Perfect. Now if you check the API part, it is running on port 11434. And this is what AnythingLLM will connect to. So Ollama is ready, let's move on. Great, next we'll see how to set up AnythingLLM. This is a RAG platform that handles everything. So let's head to anythingllm.com and download the desktop app. Click download and run the installer. You'll notice it is downloading the CUDA libraries, it is NVIDIA's GPU acceleration. If you have NVIDIA graphic card, it will use the faster processing. If you don't have, no worries, it will automatically fall back to CPU. Now it is asking to download the meeting assistant model. We don't need this because we are using Ollama for AI model. So click no and proceed. Now the installation part is completed now. Let's launch AnythingLLM. It opens up with a beautiful setup dashboard where we need to configure a couple of settings. So click on get started and follow the wizard. Next you will see it is recommended to download its own model, which is QM3 currently. Since we go with a different LLM, so let's go with the manual setup. And here is the interesting part. Let's choose Ollama and it auto detect the local host 11434 and find our local model. Right? Perfect. Now here is a quick summary which is important one to understand. So LLM provider as Ollama, which runs locally on our machine. Then the embedding, which is AnythingLLM embedder, which also runs locally. And finally the vector database, LansDB, runs locally. So essentially everything stays on our machine, no cloud, no data leaving our computer scenario here. Kind of a true private AI setup. Finally, skip the survey part, dismiss the desktop assistant for now, we are in. AnythingLLM is set up, we are ready to go with RAG in action. Alright, first let's do a quick test. I'm going to start with something simple, a basic TXT file with few lines of information. So I created this text file with fake company details. Acme Corp, CEO John Smith, founded in 2019, headquartered in Austin, Texas. Product called Widget Pro and revenue is 5 million. Now here is the thing, this is a completely made up one. I guess the specific details won't exist on the internet. and AI won't be knowing this information on its own accurately. So we'll upload this file, click on upload the document, select our file, and you will see it added a context. Now the document is now part of this workspace. Now the real test. Let's ask what is the document all about? Kind of quick summary. And look at that response. It correctly identified Acme Corp, founded in 2019, Austin, Texas, Widget Pro, the revenue and everything. Remember, this is a made up information. AI only know this because it's actually read from our document. Let's try another one. Who is the CEO? John Smith, exactly right. Now here is a key part. Click on the citation and look at this rag_basic_doc.txt reference. It's showing exactly which document it used to answer the question. So this is the RAG working. AI did not guess, it did not hallucinate, it searched from our document, found the relevant information and answered based on what it actually found. That's retrieval augmented generation in action. Retrieval, it searched the document, augmented, it added that information to the prompt. Generation, it generates the response based on that context. Now that's a simple txt file. Great, let's go with something more complex. I have a 30-page technical guide here, a PDF. Let's see how RAG handles the real documents. First, we'll create a new workspace to keep things organized. Click on the plus, call it GitHub Docs. Now let's upload our PDF. Click upload document, select the file, there it is. Click save and embed. Now it's processing, it's take a moment for larger files, and there is a reason for that, something important happening behind the scene. So let's see what's actually happened. Go to the workspace setting, vector database tab, and look at the numbers. Vector count is 21. So what does that mean? Our 30-page PDF becomes 21 vectors. In other words, the document has split into 21 smaller pieces. These are called chunks. Each chunks roughly a paragraph or a sections. Why do this? Because when you ask a question, you don't need the entire 30-page document. You just need a specific paragraph that answers your questions. So instead of searching through 30-page every time, which would be slow, the system search these 21 chunks and find just the relevant one. Much faster, much more precise. Alright, let's test it out. What is OpenClaw? How do I install it? I'm just using the readme file of our previous video GitHub document. And look at this response. Exact description, what OpenClaw is, and installation commands. Multiple method, curl commands, Node.js setup, all pulled directly from the PDF. Let's check the citation. For reference, so it searched through 21 chunks and found the 4 most relevant one and built the answer from those. This is the power of RAG. It is not guessing and it is not using general knowledge. It's finding the specific information in your document and answering based on exactly what it found. Now if you look at the system resources, I see 50% utilization on both RAM and CPU. I don't have any GPU and the network shows zeros. That means there is no cloud access and completely private. Alright, now we understand how RAG works, but remember what I said at the beginning. RAG is a system and learning how to calibrate is a skill. So let me show you what I mean and the settings that control everything. So once you understand these, you can tune RAG for your own specific use cases. So first, the text splitter and the chunking. So go to the settings on the AI provider, text splitter and chunking. The chunk size is 1000 characters, roughly a paragraph. This is how big each searchable piece is, and overlap is 20 characters. This means that each chunk is slightly overlapped with the next one, so you don't lose the context at the boundaries. Now, why does it matter? Smaller chunks give you more precise search result. You find exactly the sentence you need, but you might be losing the surrounding context. Larger chunks keep you more context together, but search became less precise. So here is the thing. Different document need different settings. Legal document with long structured paragraph might need larger chunks. Customer support transcript might work better with smaller chunks. So this is one of the calibration decisions that affect how the RAG works for your specific data. Moving on, next is the embedder. This is where the text became searchable. We are using AnythingLLM built-in embedder, all mini LM-LS6 v2. So what does this actually do? Computers can't search text by meaning, they search numbers. So this model converts each chunks into a long list of numbers called embedding. And here is the magic. Similar meaning produce similar numbers. So let me explain with an example. Keyword like dogs allowed and pets permitted, completely different words. but same meaning. Their embedding would be very close to each other. But dogs allowed and remote work policy totally unrelated. Their embedding would be far apart. So this is how the search finds the relevant content even when you don't use exact keyword from the document. It's matching the meaning, not just words. You could use other embedding provider like OpenAI, Azure, Ollama, but the built-in one runs completely locally and works great. Next is vector database. This is where all this embedding gets stored. We are using LanceDB. It's a built-in into AnythingLLM, runs 100% locally. Zero configuration needed. You could use Chroma or Pinecone or other, but for the private use, LanceDB is perfect. Think of it like pre-processed index. Instead of searching raw text every time, which is slow, we search these numbers. That is almost instant. Now let's look at the workspace level settings. Similarity threshold. This controls how closely a chunk must match your questions to be included in your result. No restriction means everything is considered. Low is 25% matched or higher, so you will get the results, but some might be loosely related. Medium is 50%, high is 75%. Very strict, only most relevant chunks make it through. So this is how it works. So if you are getting irrelevant information in your answers, bump it up. If you are getting no information found when you know it exists in the document, lower it. And the search preference default is fastest. Accuracy optimized takes longer but find better matches. So now max context snippet. How many chunks get sent to AI per questions? Default is 4. Remember our PDF had 21 chunks. When you ask the questions, system find top 4 most similar chunks and passes those to AI. More chunks means broader context but slower response, more tokens used. Fewer chunks is faster but might miss the relevant information. So 4 is usually a good balance. Temperature. This controls how creative the AI gets. 0 means deterministic. Same question gives same answers every time. Very factual, very focused. 1 means creative, more varied, more random response. For RAG, you generally want lower temperature, maybe 0.3 to 0.5. You want AI to stick what's actually in the document, not get creative and start making things up. If you are seeing hallucination even with RAG, try lower this. And finally, system prompt. These are the instructions that AI follow for every response. The default works fine, but you can customize it. For example, add something like always cite your sources. And if you don't find the relevant information in the documents, say so instead of guessing. This makes AI much more reliable. And these settings together determine how well the RAG system performs. Great, that's it. Now we are fully working local RAG system running on your machine with the complete privacy. And more importantly, you understand the core pipeline and the key settings needed to tune it for your own data. So in the next video, we'll explore the Open Web UI, a beautiful ChatGPT-like interface that adds RAG, chat history, multi-modal workflows. All the commands and the configuration for this video are in the GitHub, link in the description. If this helped, hit the subscribe, drop the comments if you got the RAG working. And if you're stuck somewhere, let me know. I'll see you on the next one. Take care.